are you, everybody who is watching this fantastic video? I'm very happy to have you today. I believe that you've made a fantastic choice to be with me today. I think even you yourself also, you are happy, or soon you will be happy. Maybe in the ministry of this conversation between I and you. And also, maybe it may be at the end of these conversations between I and you. My name is Olenjolai Moko TAYAI Losingo. Simply call me Sir Olenjolai. From Tanzania. This is our national flag, eastern of the African continent. And we are here just to transform the life of youth from one point to another point. So we thank you for your tuning, and whether that you're international or national students, or you're international or national parent or guardians or sponsor, I believe that you are going to get good news concerning about education, and especially for undergraduate students level. So I would like to take this opportunity to welcome you in online undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM. Simultaneously, we have one of our YouTube official channel that's called Online Undergrad Polyinstitute of Tanzania in square bracket OLENJOLAIM. Well, so in this online undergraduate Polytechnic Institute of Tanzania, we have a vision. We have vision, we have mission, and even we have main objective. We have also specific objectives. So I don't have enough time, so I don't think that, okay, I have prepared a special video that is called the Lecture 00, that the general introductions of the curriculums which actually I use. I declare the problems that I'm solving, because as I say that in online undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM, we have a problem that we are solving in national and international level, and have also a solutions. It means we have lay out the solution that to solve that in national and international problem. But also we have vision, okay, and also we have mission, and that's not enough. Also we have main objective, and there are specific objectives, because the word of God says that in the book of Proverbs chapter 29 verse 18, where there is no vision, people perish. If you don't have vision in online undergraduate Polytechnic Institute of Tanzania square bracket OLENJOLAIM, we are going to perish, right? So it means that I want just to spend just a minute to tell you about the vision that we have, because that vision is powerful and purpose is permanent. So this vision that we have is an assignment that we have to teach and train some group of students who will be ready to extract knowledge and wisdom from the fundamental and core courses or module that they are learning in a formal schools, or formal institutions, or formal undergraduate college, or formal undergraduate college, okay? And then combine that knowledge and wisdom extracted with the knowledge and wisdom that we have to extract, and I'm going to teach you and train you how you can extract it from the Word of God read in the Holy Bible in order to solve real life problems. So our main objective here, our destiny, to see our students, whether graduate or continuing students, are solving real life problems, even at least a small scale problems that is actually disturbing your family. So that's the vision that we have, and that's the main objective that we have. We have so many specific objectives. If you stay connected with online undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM, first of all, you love mathematics, especially if you've never loved it. And if you loved it and then you hate it along the way, believe me, your love is going to be restored. And this is one of the beliefs that we believe in many of the Tanzanians before even our best, that the Tanzanians believe that mathematics is a national disease, and we have a phrase in Swahili that called hesabu ni ugonjwa wa taifa. And I want to I disagree that phrase. It's not true. I want to tell you that mathematics is actually a great and a fantastic subject and tool to solve real life problems. So it's not a national disease, it's a solution of the national disease. That's what I want to tell you. So we have so many departments in online undergraduate Polytechnic Institute of Tanzania. One of the departments is called Department of Fire Engineering and Scientific Mathematics. And today we are teaching 12 courses or 12 modules in these departments. wonderful enough. And these 12 modules are the modules which we are taught in almost all the engineering and scientific colleges, institutions, and universities in Tanzania and even in Africa or even worldwide. Because higher engineering mathematics and higher engineering and higher scientific mathematics is universal. It's not just institutional, or it's not a university. It means at university level it's universal. So that's why I tell you that I believe that these 12 modules are going to cover everything that undergraduate students have to cover, and even subject might be beyond of what you have to cover. And these 12 modules I have a reference syllabus of the two universities and one institutions for the NACTE. That for one institution is the Dar es Salaam Institute of Technology, and for the TCU I'm using the curriculums of Dar es Salaam of University of Dar es Salaam and University of Dodoma. So we are in the institutions level today, where that the main focus of NACTE, which is National Council of Technical Education, is competence-based. So I'm going to teach you to be a competence-based. So in competence-based, we have that lectures, and we combine the lectures and the tutorials at the same time. While in knowledge-based, there's a distinction between the lecture and the tutorial sessions. So wonderful enough. Okay, so today we are still in chapter 1. We are about to finish chapter 1, which is called Theory of Limit. And the subtopic that I'm going to introduce to you today is called the continuity and discontinuity of the single variable function. Because later on in the second semester, in the second year, I'm going to teach you several variable calculus. And the several variable calculus, I'm going to teach you about several variable or function of the several variables. That's very interesting. Which the dependent variable is not only one variable. So that's why that I want to distinguish that here I'm teaching you continuity and discontinuity of the functions of the single variable, right? So stay tuned. So let me do the quick review to link the previous lecture or the previous session, which I told you, which was lecture 8, and I didn't leave the homework, unfortunately. And this lecture, it has been titled that finding delta for given epsilon. Okay? Finding delta for given epsilon. Okay, so what happens actually? We used to say that given we are still using the same principle or the same formal definition, this is still using formal definition, but in this case, we find that the epsilon is given, so you have to find the delta. So given that the limit of the function as x approaches to a, this is the function f of x, is equal to r. So he said that if for epsilon greater than 0, there exists 0 less than absolute of x minus a less than delta, and this implies what? Absolute of f of x minus limit, and then less than what? Epsilon. So we find that in the two examples that we have solved, 3 examples that we have solved, epsilon is given, for instance, maybe 1. And then we used to find the interval, let's say that negative a less than x less than a, or it might be maybe positive a less than x less than b. It was like an open interval. So we have to guess. We have to guess the value of what? Of delta. For example, if delta is 1, then we check the interval that we obtain after substituting delta is equal to 1 in order to check if it is within this range or it is on this range. So if it is on this range, if we reach the maximum to the maximum range, then we conclude that the value which gave us the maximum range of the interval, we call it that the value 40 of the delta, right? That the value of delta. So in case you missed it or you are not aware about that, maybe you got it online and you met with this lecture 9, then I want to tell you there is lecture 0 to lecture 8 in our YouTube channel. That's called Online Undergrad Polyinstit of Tanzania / OLENJOLAIM. Get in there, you'll find those interesting lectures that will transform your mind and simplify your learning process of engineering, higher engineering and scientific mathematics for undergraduate. are for undergraduate students, right? So this is lecture 9, as I said. Today, I want to teach about intro of continuity and discontinuity of the function. Remember that this is single variable function. So the fundamental question that we have, okay, this is the fundamental questions of Olenjolai. What is continuity of the function? Okay, we know the meanings of continuity and something which is continuity. What is continuity of a function? How do you define it? That's the question that we have in play. Okay? I found 3 different definitions that I want to present to you, and then we'll speak a little bit mathematically. Because we have to start with continuity and then we come to the discontinuity. So you can write here that this is all about continuity of the function. So you can write that subtitle. Okay. I think that, yes, let me write here because we are talking about continuity right now, and later on we'll be talking about discontinuity. So when we talk about discontinuity, I'll give you notification. So we say that continuity of single variable function. Single variable function. Okay? So we say that this is the fundamental question. What is continuity of the function? Okay? What is continuity of the function? What does it mean? Because you can be solving questions to check whether the function is continuous at a particular point or at a particular interval, and then our kids just see when they are dancing in our environment, when we are solving these problems, they ask us, my father or my mother, what is continuity of the function? How are you going to reply that question? So simply say that continuity of the function is rigorous, okay, is a rigorous formulation. Rigorous formulation of the intuitive concept. Intuitive concept of a function. Intuitive concept of the function that varies. Without abrupt breaks, or abrupt jumps. Okay? Or some of the books say that in mathematics, okay, the continuity of the function that does not have any abrupt changes in value. Known as discontinuity. Okay, so in mathematics, the continuity of the function that does not have any abruptly, changes in value known as what? Discontinuities. Known as discontinuities. Or third definition, then I will explain. Continuity function is a function that goes on without interruption. Without interruption, or without interruption and abrupt changes. Abrupt changes. Okay, so ladies and gentlemen, let us meditate on this three definition of the continuity of the function. And this is not for the only single variable function. This definition is valid for the single variable function, is valid for the two variable function, is valid for the three variables functions, is valid for the four variables functions. It can exist there. You have to enjoy the beauty of higher engineering and scientific mathematics. Okay, so what is continuity of the function? Is a rigorous formulation. So this is the rigorous formulation of the intuitive concepts of a function. Intuitive concepts of the function. That varies without what? Abrupt breaks or jumps. That the definitions of what? Of the continuity of the function. So it means that it's a rigorous formulations of the intuitive concepts of the function that varies. So this function is varies. What does it mean? That for instance, that we have our xy plane for the single variable function, you find that this function is varies, okay, is varies in values, for example, in this case, but there is no any abrupt breaks along from, let's say, point A to point B, for example. No any breaks along there. So there's a continuity. It means that every point is defined along that function, which we call f of x. In the second definition, you say that in mathematics, the continuity of the function, is the function that does not have the continuity in mathematics. The continuity of the function is a function. Okay, so here there's something missing. You say that is a function. So it's a function that does not have any abrupt changes in value, known as what? Discontinuities. So it means that if, for instance, you can have again another, let's say I can have another graph, for instance, that, or even this graph of AB, we find that there is no any abrupt changes in values, known as discontinuity. What does it mean? For instance, I can have also the same function, but here we have exclusive values. So it means that, let's say that this is the certain value of x naught. It means that this function is undefined at that value. So this we call discontinuous function. Or sometimes you can find that you can have a graph of the function. Okay, listen carefully. A graph of the function that we define that, let's say like this one. This we call them. Let's say that we have some special functions like in mathematics like this. Okay, we call them step function. So this is discontinuous function because the value of y here are not defined. All the values of x are defined, but the value of x or the value of y here it means at this point in this interval are not defined, they are not part of the function. So that's we call discontinuous function. Okay? So the steady definition say the continuity of the function or continuity continuity of a function, okay, of a function, is a function that goes on without interrupt or without interruption, endoti and abruptity changes. So it goes on. So these functions goes on without any interruptions along the way. So those are the definitions. So it means that we are teaching you how we can check if these functions is abruptly break or jumps. That's the concept of continuity. Okay, so we are teaching you how you can identify as engineering mathematicians. Wonderful enough. Okay, so that the definitions of what we call just like intellectual definition, okay, intellectual definition of the function. So you say that the concept of the continuity of the function is defined. So the concept of is defined. So it can be is defined in two parts. The first part we can define the continuity of the function. Continuity of the function at the point. The second, we can also define the continuity of the function. So this means that x is equal to n, that at the point. Continuity of the function, whether single variable function or multivariable function of the function, okay? Continuity of the function on an interval. Values of independent variable. So simply, we can define the continuity of the function over this range. Let's say negative a less than x less than a. Or we can define a less than x less than b. So those are the ranges that we can define what the continuity of the function. Okay, continuity of the function. Okay, so it means that we can define the continuity of the functions at the point, or continuity of the functions over the certain interval, which negative a and positive a. So let us start with how we can define the continuity of the function at the point. And then later on, I will take you to discuss that discussions today. So continuity of the function at the point. Continuity of the function at the point. Continuity of the function. So, my dear student, I'm still building the foundations of the continuity in our mind because it's a very important concept. Before even I just give you the sentence, let me give you the note. The concept of continuity is very important. So the concept of the continuity is very important in calculus and its application. So not before. The concept of continuity of the function, to know whether this function is continuous over this interval or at this point, is very important, right? So it's very important. Concept of the continuity of the function, we say that is very important It's very important in calculus. And its applications. Calculus and its applications. So let me teach about continuity of the function. Continuity of the function at the point. And this point, it is what x is equal to a, let's say. How do we define continuity of the function? So this is the way that we define. Suppose you are given a single variable function. Let me just write this one, because if you change the atmosphere later on, you at least you do remember that we have introduced this in advance, a single variable function, f of x. Okay? And then we can define its continuity. Its continuity at the point, let's say x is equal to a, as follows. First of all, we have to find the limit of lefty hand sign. Later on, I will teach you about one side continuity of the function. Okay, but right now let me give it a general definition as follows. So the first thing we say that we have to find what limit of that given function f of x as x approaches to a bar. This is limit of 40 lefty hand side. Secondly, we have to find the limit of the given function as x approaches to r positive of f of x. This is the limit of 40, so this is the limit of lefty-handed side. This is the limit of righty-handed side. Okay, and hence we have to check, means we have to check if the limit existing. Means that now we have to find that the meanings of check limit of the function as x approaches to a, okay, of f of x, which this one should be equal to the, if the limit existing, to the limits as x approaches to a of f of x, and this should be equal also the limit as x approaches to a positive of f of x, and that should be equal to what? To L. Okay, so that's very important concept that you have to remember as great mathematicians of our present generation. So then, after knowing, so it means that we now generally we know the limits of the function that existing. The second stage, the first stage, we have to find the value of the function when the value of x is equal to a. So find f of a of 40 of the function, right? So listen carefully. So then we can have mathematically. So it's mathematically say if a function f of x is continuous at a point x is equal to a, then we say that the limit of that function as x approaches to a of what? Of f of x, this should be equal to the value of that function, which is f of a. So if the function f of x is continuous at the point x is equal to a, then the limits of that function as x approaches to a should be equal to the value of the function. So my dear students, this is very important definition for the rest of your life. And this, when I teach you about my variable, functions of the several variables, we are going to modify these definitions a little bit. Do you know what are we going to say? For example, for the two variable, we are going to adjust that here to have x, y as approaches to a, b. And then here, instead of having f(x), you have f(x), y. That will be equal to what? That will be equal to the ff40, ff a, b. Right? ff(a), b. Because here, that is two variable calculus. So stay tuned. Good news is coming. So the several variable calculus, it's a module or it's a course that taught at University of Dar es Salaam and many universities, institutions and colleges of engineering and scientific worldwide. So we are going to enjoy that concept, the concept that of continuity. I have a single lecture, I've taught a single lecture. I've taught a single entire lecture about continuity of the functions or the continuity of the several variable function at the point. Okay, and that point is what is x0, y0 or a, b. So stay tuned so you can access. There is a module, there's a course that called the several variable calculus in our YouTube channel. You'll find that it's lecture 4. It's lecture 4 of that course. It's lecture 4. Because lecture 3 I talked about the limit of the several variable function. Right? So stay tuned. There's a good news that is still coming. So this is the way that we are going to define our continuity at the point. All right? At the point. So let me just talk a little bit about discontinuity, and then I will teach you about the types of rule. Yes. So I think that this is general introduction for the continuity of the functions. It's enough according to your syllabus or curriculum. Allow me, ladies and gentlemen, to talk about discontinuities. Discontinuity. I want to talk about discontinuity because we cannot distinguish. Sometimes in a problem that we be given, we can find maybe if the functions is continuous at a particular point, but it's discontinuous at another point. Right? So I think that before I talk about discontinuity of the function, let me teach you about another concept that we call in mathematics one-sided continuity of the function at the point. So ladies and gentlemen, let me teach you about the one-sided continuity of the function at the point, at the particular point. One-sided continuity of the function at the point. So you say that a function, that maybe a function f of x can be continuous at one side of the point, but discontinuous at another side of the point. Discontinuous at another side of the point. So you say that, so we have two possibilities. If the function f of x is continuous at what? At x approaches to a bar, then it means left hand side. This is the left hand side limit. So remember that I told you this left hand side limit. So you say then the limit as x approaches to a bar of what? Of f of x, this will be equal to the value of the function. So this is the mathematical formula. Okay, so this is lefty. So you say that in f of x is continuous on lefty side of what? Of lefty side of x is equal to a. Okay, so we are going. I have a problem. We are going to solve a question that that will testify that formula that I presented to you. So stay tuned. Again, in case you feel from your heart that you want to offer God your free will in thanksgiving, in order to support the running cost for this program, so that because I have a vision, we're expecting to have more than 700 videos that will be training engineering, the beauty of a higher scientific and engineering mathematics to undergraduate students of the present generations and future generations. So it means that it's very expensive and there's a high running cost for a single video to be prepared until it reaches to your place. But our God, who is a sponsor of this, or our God is a sponsor of online undergraduate Polytechnic Institute of Tanzania in square bracket Olenjolai, is more worthy than the running cost for this program. But we can invite you. He has given us permission to invite you to offer your free will in thanksgiving. Okay? Just for God, because you know this contest you cannot get free of charge if it's not God. Right? So you may send your free will in thanksgiving, or we call it just sadaka in English or in Swahili. So this telephone number 0759745331 and registered name is Olenjolai TAYAI. And believe me that your offering will be used effectively to push, it means that to support this program and not otherwise. Okay. So again we say that B, if a function f of x is continuous, okay, is continuous on the right side of the print. Let's say x is equal to a. I mean that, what does it mean? It means that x approaches to a positive. Okay? So we say that then this is how we define. It means the limit of the function as x approaches to a positive should be equal to the value of the function at x is equal to a. This is the formula. So you see, and you have example 21, we are going to use these two formulas. Okay? We are going to use these formulas. And I think that it's better if I teach you those two formulas. And then, those two formulas. But you know, there's an issue of discontinuity also in these two formulas. So I think that I have to teach you discontinuity. Then I'll teach you example 21, ladies and gentlemen. So ladies and gentlemen, now you have a fantastic foundations of the continuity of the function. Believe me. So it's a time right now to build a foundations in your mind about this continuity of the function. Are you ready for that? Do you have any questions about continuity, about the general introduction of the continuity? Ask me in the comment sections, please. Right? Do you enjoy? Do you love higher engineering and scientific mathematics? Tell me in the comment section, please. So we have discontinuity. Discontinuity of the function at at the point. Let's say x is equal to a. In some of the books they use x is equal to c. Don't worry about the variable. Those are mathematical variables. Or maybe your class teacher is using x is equal to c. Don't worry about that. You should not confused about x is equal to c, or x is equal to a, or x is equal to b. Don't get confused. Those are minor issues in mathematics. So let me give you the general definition of the discontinuity of the function. right? So generally, if the function f of x is discontinuous at x is equal to n, right? So then we say that limit as x approaches to a of f of x will not be equal to the value of the function at x is equal to n. This is all. Whether the limit of the function might not be existing, or whether the limit of the left-hand side existing, but the limit of right-hand side does not exist, or whether the limit existing, but it's not equal to the value of the functions at x is equal to n. So under that conditions, because I'm going to teach you 3 types of discontinuities, and you understand that what are the causes for the functions to be discontinuous, right? So stay tuned. So it means that if the limit of the functions as x approaches to that point will not be equal with the value of the functions at that point. Okay, understand higher engineering and scientific mathematics. In many institutions or colleges or universities, the course or the modules of calculus is being covered in first semester of the first year of the undergraduate studies. For instance, at the Islam Institute of Technology, we used to learn this module or this course in the first semester of the first year. And sometimes you can find that it's not called the calculus, it can be called the engineering mathematics 1, engineering mathematics, for example, at St. Joseph, they call it engineering mathematics 1, engineering mathematics 2, engineering mathematics 3, those are the names. Calculus is still the calculus. So function is still the function, continuity is always there. So it may be a contents of the different name from how I name the module or the course. So that's why I ask you that every time you have to make sure that you have your course outlines and you compare, because always before I start a course or a module, I give you the general introduction so that you have to know what you have to cover. Okay? So if that's the case now, let me teach you about 3 variables of fault discontinuity, and then we do the example and we end the session, because I don't want to overdose you. You're still the first year student, and I want to build these concepts in your mind slowly. Okay? Types of discontinuities. Types of discontinuities. Types of discontinuity. Types of discontinuity. Types of discontinuity of the function. Of the function. Types of discontinuity of the function. Types of discontinuity of the function. Okay. Of the function. Yeah, of the function. Okay. In calculus, or say that in mathematics, there are 3 main types of discontinuity. There are 3 main types of discontinuity of the function. Okay? Of the function. So in mathematics, there are 3 main types of discontinuity of the function. These are the first one, we call it removable discontinuity. Removable discontinuity. Removable discontinuity. Removable discontinuity. Removable discontinuity. Removable discontinuity. Okay, so I say that if, how do you define this removable? We say that if a function f of x has a limit, as x tends to c, but tend to a, but so if f of x has a limit as x tends to a, it means the limit of the function existing, but that limit of the function as x approaches to a, f of x, is not equal to f of a. The limit of the function existing, but that limit of the function is not equal to value of the functions at x is equal to a, then this is removable discontinuity. So what does it mean about removable discontinuity? We can remove that discontinuity and make the functions continuous. That's the meaning. So the first type of discontinuity of the function is called removable discontinuity. Say removable discontinuity. Say removable discontinuity. So removable discontinuity, we say that if f of x has a limit as x tends to a, but limits of the function f of x as x approaches to a is not equal to f of a, then this is removable discontinuity. It's removable discontinuity. It means that we can remove. Okay? We can remove that discontinuity and make the functions continuous. That's why we call it removable discontinuity. Okay? So we say that the discontinuity of the function, of this function can be removed. At the key point. How can we remove? Can be removed by redefining. Can be removed by redefining the function f of x at x is equal to a. The discontinuity of this function can be removed by redefining the function f of x at x is equal to a. The discontinuity of this function can be removed by redefining f of x at x is equal to what? To a. So how do we remove it? We say that if the limit of the function f of x is L, which we say it exists, then redefines what? Then redefines f of x at what? At n to be equal to f of n. will be equal to limit. When you find f of x or f of a, f of x, okay, at what? At a. So it means that after removing the discontinuity, of the function, fct of the function, so we say that now limit as x approaches to a of f of x, this will be equal to f of a, and this will be equal to limit l. Alright. High engineering mathematics is beautiful, especially in Catholic class. Very beautiful, very beautiful. Love it. Love it. I do love it for the rest of my life. Because it's a reasoning subject. The advantage of mathematics in your life, it increases your reasoning and connection of the information. Because you see, we have a problem. The function at the initially it was discontinuous, right? So then the mathematician used to think, can we remove this discontinuity? Yeah. So if we can remove, let us call it removable discontinuity. And that's what happens. So now the function is continuous. Wow. We solved the problems of what? Discontinuity. So let me draw the graph. Okay. So let me draw the graph of 40 of discontinuity, of removable discontinuity. I want to tell you that the way I learned the topic of theory of limit myself is quite different from the way I will teach you in these 10 lectures. The way I teach for the 5 years physically, my alumni or my students of Beng 15, Beng 16, Beng 17, Beng 18, Beng 19, Beng 20 at the Dar es Salaam Institute of Technology. So I taught Beng 15, my classmate, Beng 16, Beng 17, Beng 18, Beng 19, Beng 20. So I taught these modules of calculus at the Institute of Technology for the 6 years. But I told them, I learned this module less than what I'm teaching you in this online undergraduate Polytechnic Institute of Tanzania, square bracket Olenjolaim. And even those students that I taught them consecutively in 6 years, no any class that I've taught them in the highest level, like the way I'm teaching you right now. Wonderful. You have a good luck, I tell you. Myself, I didn't learn the sort of limit in this level, in this simplified language. And even I didn't teach my physical students, so it means God is doing something great. Wonderful, I tell you. I didn't know. Even you know that when I was learning myself, I just captured that there's a removable discontinuity, and then I captured the graph, that's all. But how can you remove, what happens, and how I can distinguish his other discontinuity, I didn't notice. My dear student, take these contents and this program serious for the benefit of your own life, of your family, and benefit of our own country at Tanzania, and benefit of your own country if you're watching me from any African country, from North America or South America, or wherever in the world. So this is our y-axis, and this is the x-axis. So you can have removable discontinuity of the function, right? You can have our function just like in this way. It's a polynomial function. So this is our function, and then it is continuous at this point. So this is the point we call to x is equal to a. So x is equal to a, it's exclusive. As a value is less than a are defined. As a value is greater than a are defined, except the value when x is equal to what? To a. Okay? So this we call to figure 8.1. So we say that removable, the graph of removable discontinuity. Removable discontinuity. Okay, so if this is the case that you say that you have FFXC and not the case that the removal of discontinuity, ladies and gentlemen, let me teach you the second type of what discontinuity of the function. And this we call it essential discontinuity. Say it, essential essential discontinuity. Essential discontinuity. Discontinuity. Okay, essential discontinuity. So you say that the function f of x is said to be essential discontinuity if the limit of the function as x approaches to a does not, which is simply we can call it the error, does not exist. Okay, does not exist if f has no limit as x tends to c. Okay, does not exist as x tends to a. So we say that is called essential discontinuity. It is not possible to remove this discontinuity. So it means that f of x or the function is said to be essential discontinuity at the point if the limit of the function does not exist as x tends to what? A. So we say that it's not possible to remove this discontinuity of the function. So it's not possible to remove this discontinuity of the function. It's not possible to remove this discontinuity of the function. That's all. So we leave the way it is. We can apply in some aspects of life the way it is. But we as mathematicians, we cannot remove essential discontinuity. So let me give you the graphical information to show you. So this is the y-axis. Y-axis. So this is y-axis. This is x-axis. So this is 0, 0. So essential discontinuity, we say that, let's say that this is like this, it's like this, and then we say that we can have again a continuation of the function. So this is our function f of x, and this is still our function f of x. But it is what? It has essential discontinuity in this interval values of 40 of y. So this what we call it in figure 8.2. We call it the graph of essential discontinuity. Essential discontinuity of the function. Okay, so that is Olenjolai essential discontinuity. Then the same type of discontinuity, we call it infinite discontinuity of the function. Infinite discontinuity of what? Of the function. Finite discontinuity of the function. Say infinite discontinuity of the function. Infinite discontinuity of the function. So removable discontinuity of the function, the limit existing, right? But it's not equal to the value of the function at that point. Essential discontinuity, the limit of the function does not exist, so it's not equal to the value of the function. So we have two problems in essential discontinuity. In the removable discontinuity, we have one problem, that the limit of the function existing. That's not a problem. But the only challenge is the limit of the function is not equal to the value of the functions, the value of the function at that point. In essential discontinuity, we have two problems, first of all. The first problem, the limit of the function does not exist. And the second problem, that limit of the function is not equal to the value of the functions at that particular point. Right? Interesting. So infinite discontinuity of the function. So you said the number C, the number A, so you say that for this one, this is not a good starting, we say that. The function f of x is defined or is termed or is infinite a function f of x is said to be infinite discontinuity at a point, and this point we call x is equal to a, if the limit of the function, of the given function f of x, as x approaches to a, is what? Is infinite. Is infinite. As x tends to what? Tends to a. So if the limit of the function, the given function, is equal to infinite, which that the first problem, first of all, the limit is equal to infinite, it's not defined the value. For the essential, the limit is defined. It's a defined value. But here we have two problems. One, the first problem, the limit of the function is infinite, so we don't know its value. The second problem is that limit also is not equal to the value of the function. Alright? Okay, so it's said it to be infinite discontinuity, so maybe here also you can underline essential discontinuity like this. Okay, if limits at that one is infinite, as x tends to what? To a. So limits of f approaches to infinite as x tends to c. So you say that this function, mathematically now, this function f of x is, or should have, so f of x should have something we call in mathematics, should have what? Asymptotes. Asymptotes. Say asymptotes. 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 So f of x is said to be infinite discontinuity at the point x is equal to a if limits of that function is infinite as x tends to a. This function f of x should have what? Asymptotes. Asymptotes. So, do you remember that any function in your life that is graph containing asymptotes? So for this concept that we say, remember that limit of the function as x approaches to a of f of x is equal to infinite. So because it's equal to infinite, you find the value of f of a, it's not infinite. Then you see, this is continuous function because this value is not equal to this one. This is what we define. Okay, so let me come back to the quiz questions, the quiz. Pause the video and then ask yourself, have I ever met with any function, any mathematical function that its graph contains asymptotes? Because for me, I met it before, I met in undergraduate education. Okay, pause the video and tell me in the comment section before I answer that question. Okay, so write in the comment section that, sir, these are the mathematical function which contains asymptotes. Write in the comment section, please. Mention the first one, the second one, the third one, the fourth one. I'll be happy because I will notice that you have been careful following the sequence or the process or the journey of mathematics. So you have y-axis and what x-axis like that. Okay? So the asymptotes, one of the functions now, let me mention one, but I give you the quiz, mention other three. Mention other three. Mention other four to make 5. One of the functions which have its graph, which have asymptotes is tangent. Okay? Tangent, it has asymptotes when you draw its graph. So you'll find that because the tan of 90, positive 90 degree is not existing. Why? Because it's sine 90 over cosine 90. Cos of 90, it is 0. Sine of 90, it is 1. 1 over 0, the answer is what? Infinite. So that's why that the tangent side or the tangent of the function has what? Asymptotes. Mean that the graph of tangent will never touch those asymptotes, that the meanings of asymptotes. We told you about the asymptotes in the topic that's called the function. So let us just do the general sketch of that function, okay, because we just told you that this infinite discontinuity should contain asymptotes. Should contain certain asymptotes. So this is another asymptote. Also, you can have another asymptote on this side. I'm sketching. So asymptotes in mathematics, mathematical graph, we represent them by using what? Dotted line. Okay, here we have what? We have asymptotes again. Okay, we have asymptotes again, like this. So now we can have our graph. So those are the asymptotes. Means our graph will never touch us onto those lines. Okay? So you can have our graph, for example, for the tangent. You can find that the tan of all the angles less than positive 90 existing, and even tan of 0 existing, and even the tangent of negative angles approaches to 90, to negative 90, that will exist. So this might be the graph, right? And then Again, we can have another graph here, but here we should have another asymptote. Okay, so you can have just like a redundancy of the graph, because the tendency of this function, they do repeat, especially trigonometrical function, and the tendency. So even on this side, if we have extra asymptotes, like this, so then we have this kind of the graph. Okay? So that's the graph. So it means that this is figured. This figure 8.3. So I say that the graph of 40 of infinite discontinuity. Infinite discontinuity. Wonderful graph. I think that is very beautiful graph, right? If you draw this graph on the actual data on the large paper and then put on your sitting room, then it will be interesting and will be attractive to your children and the members of your family, right? Do that, okay? So that's all about the types of 40 discontinuities. Right now, ladies and gentlemen, I want to end up this session by teaching you example 21, and then I wind up the sessions because I can blast your mind, right? So let us go to example 21. Are you ready for example 21 of the continuity of the function, of the single variable function? So example 21. So example 21, we say that refer DIT final exam. Refer DIT final exam. Question number 9. Okay, question number 9. Okay, question number 9. And then the question state that given you are given a function which is a composite function, and this function is actual x plus 1, comma, x less than or equal to 1. Then you have another function which is 2x minus 3, then x greater than 1. The question asks us that prove that f of x, so this is one-sided continuity of the functions at the point, is lefty continuous. Lefty continuous at x is equal to 1. But it is not what? It is not continuous. It's not continuous at x is equal to 1. It's not right continuous. It's not right continuous at x is equal to 1. So this makes what 4 marks. Okay, so we say that given f of x is equal to x plus 1, and then x less than or equal to 1, and then another function is 2x minus 3, x greater than 1, I have to prove that f of x is lefty continuous at x is equal to 1, but it is not right continuous at x is equal to 1. And if you do that business for that exam setup, the examiner said for 30, you are going to score 4 marks. Don't bother yourself about maybe the marks are less compared to the size of the questions. That's not your issue. The issue is, can you attempt the question? Because if you don't know it, even if that I set up exam and then some put 10 marks, then you will lose them if you don't know. Okay? So solution. So you are allowed to pause the video and then try to solve these questions yourself. You are allowed to pause the video and try to solve these questions yourself. And I believe that you will see miracles because you'll be testing if you've understood the concept. Okay, so we'll be following some steps. The first step, so because we need to prove that f of x is left continuous at x is equal to 1. The first step, we say that we call the formula of left side continuity of the function. What did they teach you? Left is this side, left hand side. So say limit of the function f of x as x approaches to a. This one should be equal to the value of the function at x is equal to a. So this is what you have to say. So suppose that this is equation 1. Okay? So the second step we have to do in order to solve that problem. Okay? So this is for the continuity. The second step, we say that we have to find limit of the function f of x as x approaches to a bar. It means this is limit of left hand side. So to find this limit, so it means that we have, when you compare with given function, so it means that our a, first of all, is equal to what? Is equal to 1. And then our suitable f of x for the left hand side continuity is this one, because here we have x less than or equal to 1, less than or equal to 1. It means that in the number line of this function, suppose that this is 1. So here on this side, this is the point we have x less than 1. On this side of 1, we have x greater than 1. So x greater than 1, this will give us right hand side limit. And this will give us left hand side limit. Remember, in the previous lecture, I believe that was lecture 3, I told you how you can find the limits of the composite function. So we are doing the same story here, but here we are finding the limit and also we have to find the value. Okay, so for this case, our f of x is equal to what? X plus 1. Right? X plus 1. That is, so x plus 1. So as x less than or equal to 1, that is good. So it means that fine, so you have considered left hand side of equation 1. So then now we say, aha. So you're looking limit as x approaches to 1. Okay, 1 bar, and our function is x plus 1. So if we use the table methods and the scientific calculator to find the limits of left hand side, then as x approaches to 1 but not equal to 1, we find that the limit is equal to 2. Okay? Then we go for the same step. The same step, we say that we have to find f of a, or when f of x means the value of the function of this function when x is equal to a. Right? How do we find this value of the function? So to find the value of this function, we have to consider the x value which have less than or equal to a, or the function which has domain. This is the domain. Domain is x less than or equal to a, or the function which have the domain which is greater than or equal to a. These are the two functions that we can use. These are the two functions in the composite function we can use to find the value of the function. It means that it should be should be less than or equal to a, or in some scenarios x should be greater than or equal to a. But when we find x is less than a, that is not a suitable domain to find the value of f of a. And also, if you find that x is greater than a, that is not a suitable value to find the value of the function. I'm going to repeat this concept until it's written in your mind. We have 4 inequalities, right? This inequality of less than, let me repeat, and the inequality of greater than in the composite functions that when you are dealing with limit and in continuity. This will help us to find the left-hand side limit of the function and right-hand side limits of the function. Again, these 2 inequalities, less than or equal, and the greater than or equal, also will help us to find the limits of the function. This will help us to find the limits of the left-hand side function, and this will help us to get the limits of right-hand side of the function. But for the value of the function at the point, we are going to choose the function which the domain are either in this form or this form. We will never use any function which its values is, its domain is less than or it's greater than. I will repeat this concept until it's written in your mind, because this is the trick. It's a secret. Many students, they don't know. And wonderfully enough, even many teachers, they didn't discover it. Even myself, that it's a grace of God that helped me to discover it. Because I've been pondering these informations and asking myself, what's going on here? Right? So for that case, for all the values of f(x) is equal to a, or f(a), we are going to use this function because the only components of the composite function which has less than or equal to this function. All right? Okay. So to find FFA, we say that our f of x that is suitable is x plus what? X plus 1. So to find f of a, what the value of a, it is 1. Okay, if you substitute here, we get to 1 plus 1 is equal to 2. Alright, so we find that, so suppose that this is, it means this is our second equation. And then here we found that f of x is equal to 1, which is equal to f of 1. This is equal to 2, and this is equation 3. So we go to the first step. The first step, we say that substitute equation 2 and what? And 3 in equation 1. So to substitute it, what's going to happen? Okay, so we find that 2 is equal to 2. So we find that, therefore, our limit of left-hand side as x approaches to a of f of x is equal to f of a. So the question was asking us to prove. So if it's proved, so we say that hence proved that the first part of the question. Did you understand what am I teaching you? Tell me in the comment section, please. I'm waiting your feedback to make the complete cycle. To complete the cycle, we call it we need the feedback, to have a feedback system in electronics, in electrical system. Feedback system very important. So tell me in the comment section whether you understand. All right, I'm waiting your comment. Okay, so hence proved it. Then we go for the next part of the questions. We have also to prove that it's not right continuous at x is equal to 1. So the good thing, we don't need to find the value of the functions again at x is equal to 1 because it's the same. So we go to the fifth step. The fifth step now, we say that, recall the formula of the right-sided discontinuity. Right-sided discontinuity of 40 of the function. So if the function is right-sided discontinuity, we say limit of the function f of x as x approaches to a positive, this will not be equal to the value of the function f of a. So this will make us what? Equation 4. Do you love now mathematics? Is mathematics beautiful? Yeah. So, if this is the case, we say that, okay, fine. So it means that consider, so you say, okay, so the sixth step, we say that consider lefty hand side of 40 of equation 4. So you have to find limit of the function as x approaches to a bar, a positive. Okay, how do we find this? We give us our function. So it means that this function for the composite function, because our original function was f of x is equal to what? X plus 1. Then here we have x less than or equal to 1. And also another function, it is what? 2x minus 3, 2x minus 3, but this is for x greater than 1. So this domain and this function will give us the limits of left-hand side and also will give us the value of the entire function. Right? This domain of this second function, right? Second function. So it will give us the limit of right-hand side. Why? Because I told you that in the concept of the limit, suppose that this is your number line. Here we have 0, here we have 1, here we have 2. Right? I told you that this is the point where we have x less than 1. And this in mathematics is called that x approaches to a bar, if you do remember. And as I told you that in this point we have x greater than 1. So at this point you say that x approaches to a positive. So to find limit of the function f of x as x approaches to a positive, this implies that you can write that it's the limit as x approaches to 1 positive or 40 of the f of x. So what function are we going to use? The second function. So I say that the limit of the function of what function? Of 2x minus 3 as x approaches to 1 positive, right? 1 positive, and hence this one is equal to what? So if you substitute here, we have 2 times 1, then minus what? Minus 3. So the answer here is equal to negative 1. So it means that the limit of the function as x approaches to a bar, right? F of x, this is equal to the limit as x approaches to 1 positive bar or 40 of f of x is equal to negative 1. And this is equation what? So you can consider that this is equation what? 6. Question 5. Okay, question 5. Wonderful. I tell you, my dear students, I have never taught these concepts of continuity and discontinuity in this level. Real, I want to tell you that there is great revelations in this session that are upon me. This what I'm teaching you, it's both. I want to tell you, it's almost. I have prepared 60%, and 40% is God is pouring to me for you right now. So give thanks. I give thanks for what God is doing in this session, because in this lecture, because I'm teaching you extraordinary in very simplified language that I've never spoken about. May God bless you. Okay, so then, we say that we go for the 7th step. The 7th step now, we say that substitute equation what? Substitute equation 5 into what? Equation 5 and what? And the equation and equation 3 and equation 3 into equation 4. Wonderful enough. So where the equation 4? This one. What the value of f of x the limits of the FFX as x approaches to a positive. This one, negative 1. What the value of FFA? This one, this 2. So you say, okay, is negative A not equal to 2? Yes. So you say that therefore, the limit as x approaches to A positive, approaches to 1 positive, right, or 40 of the function f of x, this is not equal to what? It's not equal to f of 1. Hence what? Hence proved. My dear student, I can keep on teaching you and teaching you and teaching you. I would like to say that this is the end of lecture 9. Join me in the lecture 10 when I will teach you about the continuity of the function at the interval. And I'm going to solve actually the questions which used to appear or in the test 1 or even used to appear in the test 1 and appear in the final exams of many institutions in many universities or colleges, which actually you can win 10 marks. So I will solve in the lecture 10, which will be the last lecture for the topic of theory of 40 of limits. So don't miss it. This is Olenjolai, come from Tanzania, beautiful country where God lives. I thank God who has created me in his own image and likeness. And I thank God who has built the teaching industry and teaching gift in me. And I thank God who have given me this special invitation to offer my gift to the as a gift or as a offering to him through the Tanzanians for the present and future generations. And I thank God who have given me everything that I have, and who has given me understanding on teaching you by using the digital technology and impacting the present and future generations and write history in your life, in your community. I thank you also who have taken your time to learn with me. In case you have any questions, don't hesitate to ask me in the comment section. But remember that in online undergraduate Polytechnic Institute of Tanzania, especially in our YouTube channel that's called the Online Undergrad Polyinstitute of Tanzania and square bracket OLENJOLAIM, we are going to add at least one video in a day. Every day we are adding at least one video in our channel. So for you to be notified, because we don't have any mechanism to inform all our students worldwide, possibly that hundreds of our students or maybe thousands of our students. So for you to get notification, please remember that to click the buttons of 40, subscribe. Okay, subscribe. Click the buttons of 40 of subscribe. Right? And then once you click these buttons of subscribe, then the bell appear, choose the option, click the bells and choose the options of all. You are already registered. But you cannot subscribe without having an email. So make sure that you have a valid email, you have to sign in, then you can subscribe. Once you subscribe, when we add a video and we have possibly 100 subscribers or 1,000 subscribers or million subscribers, instantly as I publish any video of higher engineering and scientific mathematics, the YouTube community has the mechanism of using the internet and inform all my hundreds of students or thousands of my students or millions of students at the same time that Olenjolai has added a new video. Right in Tanzania, in Online Undergrad Polyinstitute of 40 Tanzania and square bracket OLENJOLAIM. So remember that to subscribe, share these contents. I wish this contents to spread in the entire country of Tanzania, in all institutions, in all undergraduate engineering institutions, in all undergraduate engineering college, in all undergraduate engineering university, and including scientific colleges, institutions, and college and universities that is in mainland of Tanzania and also in Zanzibar and Pemba. So, my dear student, may God bless you. I'm praying always for you. I ask you to pray for me. In case you feel you want to offer free willing thanksgiving, don't hesitate yourself, because you'll be a part of this program for the benefit of yourself, the members of your family, and even your incoming children who will be doing or will be studying mathematics for the rest of their life. So stay tuned. I invite you in the lecture 10 when we are going to wind up the topic in the first chapter of the Theory of the Limit. So don't miss it. Get prepared, be serious, and have a focus. Remember, think that how you can apply this information to solve real life problems. May God bless you. I love you so much. I'll meet you later.